B, so please pull your notes out. We've just got 3 questions here, and this will be able to get you to do most of question 3, and then maybe tomorrow we'll have a look at some of question 4 together. I think it's a pretty good idea. So we've got A, write 14 on 19 as a terminating or recurring decimal. So all we're going to do is put that in our calculator, and it's got a lot of figures, so I'm just going to round it. 0.736. I'm going to round the 8, so 0.7368 is 0.737. Okay, part B. Show that the number 0.45 recurring is rational. So it wants us to write 0.45 as a rational number. So 0.45 recurring, like what does that mean? It's like this, isn't it? 0.45, 45, 45, 45, and it just keeps going forever. That's what recurring means. So what we're going to do is we're going to let x equal 0.454545. Okay? And then we're going to find 100x. Okay? 100x. And if I multiply this side by 100, it's going to be 45.45, 0.454545, okay, etc. Alright, so watch this clever thing here. And then what I'm going to do is I'm going to take away x from both sides. So I've got 100x take x, and I've got 45.4545 recurring. I'll leave it like that, take x. Alright. Now over here we've got 100 take x, that's going to be 99x. And over here we've got 45.45 take x. Well, what is x? X is this 0.45 recurring. So it gets rid of that part there. And so I'm just left with 45 here. And then divide both sides by 9. X is 45 on 9. On 99, sorry. And 9 is a factor of both of those, so 5 on 11. Okay? So, what did we do? We said, here's the recurring decimal, let's define it as x, then we multiplied it by 100. The reason I multiplied it by 100, right, is what I want to do is I want to have the recurring decimal as a whole number on this side of the decimal place. So that's the whole recurring decimal, the whole recurring number before the decimal place. Okay? So that's why I multiplied it by 100. There are instances, if we had 0.7 recurring, okay, we just need to multiply that by 10, okay, because then that's going to make it 7.7 recurring. If we had 0.421 recurring, then we need to multiply it by 1,000, so we can have 421.421, 421, etc. Okay, so if there's one number, we're multiplying it by 10, by 100, by 1,000, and so on. Okay, that's just the rule. That's what we're multiplying it by. Okay, and then we've got this statement. Well, that's 100x. We take away x from both sides, so we can get rid of the decimal part. Okay, and then we have 99x is 45, and we just solve. Okay, so how about this? This is pretty amazing. We have 9.9 recurring equals 10. Is this a true statement or not? Yes, it is. We've got a few nods, so we've got a few smart people around the place. Yes, it is. Yeah, like you might think, no, they're different numbers. 9.9 recurring is different because that's just 9.999, and that's just 10. Okay, so how do I prove this again? So what we'll do, we can let's let x equal 9.9 recurring. Okay, and then if we find 10x, we've got 10x is going to be 99.9 recurring. And then if we do 10x, take away x, it's going to be 99.9 recurring, take away x. And so here we're going to have 9x. And over here we've got 99.9 recurring, take away, what is x? X is 9.9 recurring. That's going to leave us with 90. And so we've got x is 10. And so we've got x is 9.9 recurring here, and we've got x is 10 down here. We've proved that 9.9 recurring is equal to 10. Super fascinating, super fantastic. Cool, so that's enough to make your way through some of 7b, but question 4 we'll do tomorrow. Okay?